So now that we've talked a little bit about the fork join framework in general, it's time to start taking a look at some of its key constituent components, beginning with the Java ForkJoinPool class. And we're going to talk about all the different parts of the fork join framework eventually. And as you can see, there's lots of different moving parts. But let's start off with the fork join pool. And as you can see from this diagram, fork join pool actually will extend some other classes in the Java executor framework. And those other classes in turn implement various interfaces we've talked about previously. So the fork join pool class implements the executor service interface indirectly. So we've talked about executor service before. You've had a chance to program with executor service, and the fork join pool is an executor service, but there's a lot more to it than that, actually. The executor service interface is the basis for a whole pile of subclasses in the Java executor framework. As you can see here, executor service, which is going to extend the executor interface, is then also used with the abstract executor service, the thread pool executor, fork join pool, scheduled thread pool executor, and so on. And we'll see that some of the other implementations of the executor service can be used to execute runnables or callables. If you recall, for example, the executor interface is used to process runnables. The executor service is used to process callables or runnables, and so on and so forth. The fork join pool can also execute callables and runnables, but that's really not what it's there for. Its purpose in life is not limited to runnables and callables. It really is designed to execute things called fork join tasks. And not surprisingly, we will soon talk about what a fork join task is. Right now, though, just for completeness, if you take a look at fork join task, you can see it's got a couple of methods that are important, namely fork and join, which is what makes it a fork join task. Again, the fork join pool is also well equipped to execute or handle runnables and callables, but that's not really the purpose that it serves. Although you can do it, you can use it for that. But if you're going to do just runnables and callables, you're probably better off doing something like the thread pool executor. But we'll talk about that in more detail. Now, here's a little bit of interesting design trivia. There are intentionally very few knobs that users can set to control a fork join pool. As you can see from this API here, most of what you have is the ability to submit various kinds of tasks, be they runnables or callables or fork join tasks and so on. And you can shut things down. And that's about it. There really isn't a whole lot more. It's kind of the equivalent of the old one-button mouse that was popular with early versions of the Mac. And the reason to do this, the reason why they kept the interface so simple, was so that programmers don't need to worry about tuning the way in which the fork join pool behaves. And so if you take a look at this wonderful video by my friend and colleague, Doug Lee, who's the author of fork join pool, he talks in detail about the design rationale for fork join pool and compares and contrasts it with other portions of the Java executor framework, which are much more complicated. In particular, the thread pool executor, which is another framework that's part of the Java executor framework, has a lot of knobs. So it's like a gaming mouse where you've got dozens of buttons on there. And if you take a look, here's just the interface for thread pool executor. Compare and contrast that with fork join pool. You can see that it's much more complicated, and there's all kinds of behaviors you can tweak and preferences and policies and so on and so forth. And so it's much more complicated. For example, you can control the core pool size, the max pool size. You can dictate the type of work queue, how long threads in the pool will keep alive if they're not in use. You can define how the threads are created. There's a way of being able to handle rejected requests, et cetera, et cetera, et cetera. So all kinds of knobs that can be turned. And the reason for doing that was they wanted to make it maximally flexible for developers to customize and tune the thread pool executor. But fork join pool has a different design goal. And so it's meant to be very simple and meant to be so done so cleverly and so optimally that you shouldn't have to fiddle around with various knobs. There are, however, a couple of things you can do with a fork join pool. And in particular, there's something called the common fork join pool, which you'll get a lot of experience with in our upcoming programming assignment. And one thing you can do with a common fork join pool is you can configure the number of threads in the pool. And there's a couple of different ways to do this. One way is to explicitly set the number of threads in the pool before the program starts to run. And we'll show an example of that and talk about the pros and cons of that approach. And then the other thing you can do, which is really more flexible but a bit more complicated, is dynamically adjust the number of threads in the pool by using something called a managed blocker. And you'll get a chance to play around with managed blocker in programming assignment 4A as well, because we'll use that as one of the ways of being able to control the number of threads that are part of the common fork join pool. So that's the end of the quick overview of the Java fork join pool class. Of course, we will come back later and talk about the methods that it provides in more detail. So this, again, is just meant to give you kind of the Gestalt perspective that covers the forest view as opposed to getting into the trees.